In today's class, we'll be studying the topic pattern-based software design. Now, this answer is important for 5 marks. You can get it as 5-mark answer or as the 17th question where you have A, B, and C bit. You can have this pattern-based software design asked within that. Now, what is pattern-based software design? Now, within the previous classes, we have studied about the design process. We have studied various design concepts, how they are applied. We have studied. Now, with throughout the design process, whenever this design process is being carried out, you're going to have a software engineer. Now, the software engineer's job is that he's going to look for every opportunity where he can reuse specific components. Now, why he's going to focus upon reusability? Because reusing the components, it is going to reduce the cost of building, and it is also going to reduce the time to deliver the software within the specified time frame. So within the entire design process, the software engineer is going to focus upon every opportunity to reuse any existing design pattern so that it can reduce the cost and time rather than creating new ones. He's going to reuse rather than creating new ones. Now, what is the definition for pattern? A design pattern, it is a general repeatable solution to a commonly occurring problem within a software design. Now, if suppose you are looking for furnishing your home, so you're going to have different patterns. That is where you can, how you're going to organize your home. Now, within this reorganization, it means that this is a solution. Repeatable solution means as you're focusing on reusability, you're reusing some specific solutions on different areas of your home. So this is a repeatable solution for a commonly occurring problem within the software design. Now, within the software design also, you're going to identify what are the different components, how these components need to be placed, what should be the relationships. That is also the same thing. So you're going to focus upon how these patterns are going to be reused, how these components are going to be placed within the software. Now, within this pattern, you're going to have 3 different things. That is how you're going to describe a design pattern, using a pattern in design. Now, within this, you're going to have 3 different patterns and frameworks. Now, starting with the first one, that is describing a design pattern. Now, when you're describing a design pattern, now what is describing? Describing is description. Now, within describing design pattern, the 3 things that it's going to do. The first one is it is going to describe the design pattern. However, you're describing your design pattern, the description of your design pattern may be considered as a set of different design forces. Now you might be wondering, what are design forces? Now, this design forces, they are going to describe various non-functional requirements. Now, let me first give you a few examples of non-functional requirements. Example of non-functional requirements, it includes what is the ease of maintainability. Now, ease of maintainability means how easy it is to maintain the software, that is giving different updates within the software. Maintainability, 1 second. The ease of maintaining the software and portability. Now, what is portability? Portability means whether the software, whether it can run upon a different operating system without any change within the result. So the description of design forces, it is going to describe different non-functional requirements. Now, these non-functional requirements, or you can say these non-functional requirements, these are associated with how you're going to apply the software. This is all is going to tell you how you're going to apply a specific pattern. So this is the first thing. Now within the description of the second point is, it is also going to describe the environment and the different conditions that need to exist so that you can apply the pattern. So there are two things for applying the pattern. First, the different design forces so that you can apply the pattern, and the different environment and conditions so that you can apply the patterns. The next thing is, it is also going to tell you what are the different pattern characteristics. Now the different pattern characteristics, they include what is a class, what are their responsibilities, and how these classes are going to collaborate. Now, as these are the different characteristics of pattern as these are different pattern characteristics, these pattern characteristics, these can be adjusted. That is how many different classes it can accommodate, or adding a few responsibilities, removing the responsibilities, or identifying how these are going to collaborate. These can be adjusted so that you can have a variety of problems that can be solved. So that variety of problems are solved. Now the next one, that is the most important, as the name suggests, describing a design pattern. Now within describing the design pattern, you are going to name the design pattern. Now whenever you're naming the design pattern, you are going to give a meaningful name. Now giving a meaningful name, it is very important. Now why it is important? Because if you're searching for a relevant pattern, this name is going to aid your search. It is going to give you more efficient results. More efficient results you're going to get based upon the name of the software. So that is your describing the design pattern. The next one that we're going to study, it is using the architectural pattern. That has got 3 patterns in here. The next one is using patterns in design. Now, when you're using patterns within the design, there are a list of patterns that can be applied throughout the software design. The first one in which is the architectural pattern. Now, within this architectural pattern, it is going to define the overall structure. Now, this overall structure, it is going to be for a software. It is going to define the overall structure of the software. When you have a structure of the software, you also need to know what is the relationships. So it also going to identify the different relationships. Now, these relationships, it is going to be among the different components. Now, within the architecture, you're going to have multiple components. So you're going to have relationship between all these components. Now, apart from this, it is also going to tell you what are the rules among the different elements. What are the rules of the different elements? Now, within the rules of the elements, you're going to identify any rules for classes, or what are the different packages that you're using, or the different components. So this is your architectural pattern. Architectural pattern is going to give you an overall structure of the software and relationship between different components. One thing. Second, it is also going to tell you the different rules for your different classes that you're using, packages and components that you're using within the software. The next pattern that you're going to use, it is called as your design pattern. Now within this design pattern, it is going to address a few specific elements of design, like the aggregation of components to solve a problem. So this is going to tell you how you're going to combine the different elements, the different components, so that you can solve a problem. Now the segregation, it is also a relationship. Now the segregation symbol, it is represented by a straight line and a hollow diamond. Then the third pattern is idioms. Now these idioms are also called as your coding patterns. Now coding patterns, these patterns are based upon specific languages. Like we have got, so you got C code, Java code, .NET codes, you've got different codes. So these are language specific patterns. Language specific patterns. Now these language specific patterns, they are going to implement algorithms, algorithmic elements of specific component. That is, you're making use of a particular algorithm for the execution of the task of a particular component. And within this, you're also going to identify what is the point of interaction, that is your interface, and how you're going to communicate between these different components, that is also going to be identified. So these are the three patterns that are going to be used. Idioms are coding patterns. Now these are based upon language specific patterns, that are like you have C packages, you've got Java, for different languages, you've got different algorithms. Now this, you've got entire code is different for each and every language. Now this language specific pattern, they are going to implement algorithmic elements of component. That is, if suppose a component is making use of algorithm to execute a particular task, so that are going to be executed within this coding patterns. Within coding patterns, you're executing a specific algorithm. You're going to identify if there is any interface, and you're also going to identify how there is going to be communication among the different components. So there's the second part, that is using patterns in design. Then the next one, third one, is framework. Now framework, it is actually not an architectural pattern. But it is called as a skeleton. That is a collection of plug points. Now what are these plug points? Can also be like different slots. So these plug points are going to enable to adapt, like these plug points, these are very adaptable to every problem. So plug points are going to enable the designer so that they can integrate different classes or different classes and functionalities within the skeleton. So the software designer can enable different set of classes and different functionalities within this skeleton. So this is a framework. It is not an architecture pattern, but it is like a skeleton. Now within the skeleton, it is a collection of different plug points. Now what is going to happen within this plug point? These plug points are like your switches. Like these are your different slots. Now these slots this is going to enable them to make it more adaptable to the solution. That is, if suppose the particular problem requires some specific features, it is going to make it more adaptable. If you want to port the particular program onto another operating system, it is going to be adaptable. Now this plug points, they are going to enable the designer to embed different classes and functionalities within the skeleton. Now framework, basically it is also called as a skeleton. So with this, we finish pattern based software design.